Good morning, physics students. Again, we recently did this flying pig experiment in class, so we're going to take a look at some of the vectors and forces acting on this flying pig. So the toy pig flies in a circle at constant speed. This arrangement is called a conical pendulum because the supporting string sweeps out a cone. Neglecting the action of its flapping wings, only two forces act on the pig. Gravitational mg, which we've previously just called the weight, and the string tension T. Vector component analysis. Note that vector T can be resolved into two components, horizontal Tx and vertical Ty. These vector components are dashed to distinguish them from the tension vector T. If T were somehow replaced with Tx and Ty, so if instead of holding this with this one string here, if we held it with a string here and a string here, the pig, blank, behave identically to being supported by T. It would. Okay, so it would behave exactly the same way. Since the pig doesn't accelerate vertically, so what we're talking about here is the pig isn't moving up or down, it's just moving in this circle, okay? Since the pig doesn't accelerate vertically, compared with the magnitude of the weight, component Ty must be equal and opposite, right? Because those are the opposite, okay? These two components, right? That's the equal and opposite, which are keeping it from the pig from moving up in the air or falling down. Number 3, the velocity of the pig at any instant is blank its circular path. It's tangent to. Tangent means in a straight line. So basically what it's saying here is this pig is constantly trying to escape, okay? But it is this tension in the string that keeps pulling it back. If I let it go, this pig would move off in a straight line path. Since the pig continues in circular motion, component Tx must be, well, if it's circular motion and it's towards the direction of a circle, the inside of a circle, it has to be a centripetal force, which equals our mass times our velocity squared divided by our radius. Furthermore, Tx is blank, the circle swept out. It is along the radius of. Right, so here's our circle, here's our radius. Our component, our horizontal component of the tension is along that radius. Vector resultant analysis. Rather than resolving T into horizontal and vertical components, use your pencil to sketch the resultant of mg and tension using the parallelogram rule. So what it's asking is for us to just take this and again use our parallelogram rule. Okay. And we want to be this. So our resultant, okay, is right here. The resultant lies in a blank direction, so it lies in a horizontal direction, and blank the center of the circular path toward the center of the circular path. The resultant of weight and tension is also centripetal force because it's acting towards the center of a circle. So that's what kept our flying pig in action. So again, idea here is it doesn't matter whether I look at this tension initially, look at the tension, or resolve it into the resultant of these two. Either way, I get that the net force acting on the pig is always a centripetal force towards the center of a circle. Have a great day.